All right.
Limited dynamic range.
Beautiful. What a precious thing. I don't know. Give me some rough idea of what your experience is and what you want to get out of this. Because, I mean, we can get, not today. Today we're going to be getting to know each other. But in future sessions, I mean, we can get just as geeky as you want to. I mean, we can be Martians. Otherwise, I mean, I don't know what everyone's level of experience is in dealing with processed audio.
I think probably everybody in attendance is going to be responsible for setting the processing up for their respective studios. So,
AM, FM recording, or all of the above?
All of the above.
Okay.
One of the things I think that a lot of people might be interested in is one of the common pitfalls that everyone falls into when tuning, is probably, is there like a common pitfall that everyone gets into and how to not do that?
Yeah. Oh, yeah. In fact, I'll go ahead and give you a spoiler alert. The biggest one is the way you want to adjust is make very small changes and ideally sleep on it, because it's going to be different on different tunes. I've talked to Frank Fody about this by email, and it was funny. Frank shared a paper that he was getting ready to prepare. There was a song, I think it was by Kelly Clarkson, and he said they had just finished putting all kinds of new tweaks on an Omnia on their latest limiter. That one song sounded like crap. And he said they had to go tear into the code and figure out why. So that's probably the biggest thing to start off with is don't think that you're going to sit down and in a 15-minute session have a market-dominating sound. It does take time. It takes patience. And you also need to listen on speakers that are equivalent to what most of your listeners are using. I mean, don't go into the studio and listen to the big Tannoys or the JBLs. You need to listen more to what they're going to be using. But anyway, sorry, go ahead.
I was just going to say, so I was doing it right when I'm doing the tuning sitting in my truck?
Absolutely. I think it's perfect. Of course, it depends on your truck system. I've had rental cars. I travel a lot, and I rented one time. I think they were the Beats. That was the worst sounding stereo I've ever heard. It had a nail in the response at like about 80 or 90 hertz. Drove me insane. So I could see myself adjusting around that. But if you have a good stereo, absolutely.
I think the other thing, Stephen, is that most of us, you set it up and then the boss says, that's great, don't touch it ever again. So a lot of people, they've done it once or twice, and then unless the format changes, the boss doesn't want them playing with it.
Well, and I can understand that. So obviously there's going to need to be communication. Some things I'm going to show you. I tried to get some videos in here. I wasn't terribly successful. Maybe I can do it in the future. But there are some very simple demonstrations you can give to your coworkers, some of which will absolutely blow their mind. But and you can show them. I'm going to get into some of that with the psychoacoustics and fun stuff. But okay, I'm making notes here. But basically, you probably know this. The key to a loud, clean signal. First of all, none of these is avoidable. You have to limit your dynamic range. That's the first thing, obviously. For those of you at a classical music station, you're going to be in a battle with people. Maybe you can get by with a limited dynamic range. I'm saying what limiting. In other words, like maybe a 2-to-1 or at worst a 3-to-1 compression ratio. And for those who might not know what that is, we'll explain that shortly. But that's the first thing. You limit your dynamic range. The next thing is you limit your peaks. You already know that. Now I'll show you a couple of photos in a minute that show you why you have to do this. because the peak to average ratio on most audio is surprisingly large, especially speech or electric guitar is how I discovered it. Really just about any guitar or any percussive instrument, piano, drums, you try to record them, you'll set it up and you've got your meters doing pretty well, popping around in the middle. Then you listen to the recording and it is horribly distorted. The reason is because of that high peak to average ratio. And then finally, this is another one that some people don't want to hear. Very carefully and very judiciously limit your bandwidth. And the reason is because it takes a ton of power to produce deep, deep bass. And especially, we'll get into some special tips of processing for streams, which would include, you guys have HD in Canada, right?
Yeah, we do. Yes, we do have
Do
some
any of you
stations.
currently run HD?
I've got one running HD and one about to go HD.
Okay. Well, you know that essentially is a band limited stream. So we can treat it the same as we would what you're putting on your web stream as far as processing. And I'll show you one of the tricks to make it sound good, because if it's a low bit rate stream, your high end is going to be very gnarly sounding. You already know that from listening to MP3s. So one of the keys, unfortunately, you have to roll off the treble just a little bit, just slightly. Excuse me. I don't know about you guys, but we have lots of sinus issues going on right now. And all you have to do is go into a grocery store coughing and people say, he's got COVID, and they all run. It's beautiful. All righty, let's see. If you have one of these, tell management you're not going to be able to do much for them. That's the bad news. The good news is, if you have one of these, it could be worth a lot of money. There are recording studios now that are paying through the nose for things like, I hope you can see this, it's an old RCA. You can also, if you have an old, years ago, we changed out some equipment at an AM station, and I took an old gate stay level and I threw it away. Now it would be worth thousands and thousands of dollars. Old Uri's, the ones with the optos in them. There, you have an old one, you may not be able to use it on air, but you could sell it and possibly have more than enough money to buy a very nice processor. You just call the recording studios and say, hey, I've got an old stay level and it still works. They're probably going to crawl all over you. Here we go. This is a little bit more modern. This is one of our processors, just one shot of an Omnia 11. You can move. Can you see the mouse cursor? Good. What you're doing, anybody up there have the Omnia 11 or the Omnia? You do? Good processor. Very good processor. But as you probably discovered as soon as you look at it, there are a million things you can do, and it's very easy to come up with a horrible sound on it. The interesting thing with the Omnia is 5 separate limiters. And then they have a final broadband clipper that takes care of overmodulation. And incidentally, Frank Fody will tell you he uses 2 completely different clipper methodologies for streams, which again includes HD, and your on-air signal. The on-air signal can be really more of a traditional limiter, just snipping off the tops of the audio, albeit a lot more sophisticated. HD needs a look ahead that can actually reduce the gain a few milliseconds before the peak happens, because the codecs for your streams have so much trouble with sudden changes, which is why the highs sound bad. But they use a 6-band limiter. I said 5. 6-band, 5 bands of broadband AGC. You can see we have 2 STLs feeding this because we don't want to go off the air. This is one of our most important radio stations. One thing I love about people, the folks at Telos Omnia, they have a sense of humor. And I love the names they have for some of the adjustments, like Sparkle. You go, in other words, there's one whole page that has nothing but fat bass, all other kinds of fun things. Play with them. Don't change more than a decibel or two, though, because you can very quickly muddy up your signal if you're not careful. This is another processor that we've used. Very good sounding processor. Really, you put this in the same rack with an Omnia, it's hard to choose. If anything, I have to say, I think their limiting is just a little bit cleaner. And the reason for that is because they have a 31 band limiter. 31 bands. They divide it up, starting with the super deep bass all the way into the highest treble. And they clip each of these bands separately. And then they also have, just like Omnia, I mean, I want to be fair, they have distortion correction, pre-correction, you name it, they've got it. This is another one that has a million different settings, and you can easily get lost. So we're going to go, I'm thinking, and you guys can overrule me if you want to, what I'd love to do in a later session, we will actually take some processors and set them up so that we can hear what they sound like. And this is a good bargain processor, just happens to be from Wheatstone. Omnia also has one, has a couple of lower price models. This is the Wheatstone FM55. We bought it for one of our translators, and it is surprisingly good sounding. Does a very good job for us. The one thing that Wheatstone has, Omnia does it slightly differently, but they also have stereo enhancement, but at the same time, it's an enhancement that is program-based. And what that means is they're not going to blow up the stereo enhancement on something that didn't have a lot of stereo to start with, like a voice. And the reason they do that, as you probably know, a lot of stereo enhancement is going to cause problems for multipath. You really start sounding grody with multipath. Let me see, is that on there? No, I don't have the stereo enhancement, but they have it too. It's control. There it is, down near the bottom. Stereo enhancement. Set it for 5. There's your density, which we're pretty dense, even though we're in a mountainous area, but that's because the Omnia knows how to reduce the enhancement on signals that don't have a lot of stereo to begin with, a lot of separation. Let's see what we got. I found this image online, and I thought this was hilariously fun. Has nothing to do with audio, but it has everything to do with the fact that our senses, smell, sight, taste, touch, and hearing, are interpreted by the brain. And it is absolutely crazy. The fact is, I want you to look at that square, at the checkerboard. In actuality, A and B are exactly the same color. They are the same color. These little boxes here show that, and what I literally did, I was using a paint program. I went in and used the little color picker, the little sipper tool. Sip that color, made a box. Sip that color, made a box. They're exactly the same color. Even though I'm telling you that they're the same color, and we could zoom in on this, we can zoom out, you're still going to see 2 different colors in the checkerboard. So that's the first thing you learn about the brain here, is that the brain can be fooled. As it turns out, though, with audio, that's something we can use to our advantage. One of the tricks that we use to hide clipping artifacts and other things that we might add in processing is masking. You've probably heard of this. The better codecs use masking extensively. And if it's stereo, they're going to use the masking in both channels to the extent that, like, for example, if you have a loud trumpet in the right channel, but the left channel is relatively low level, you can really degrade that left channel and save some bandwidth. And that's what they do. Now, when you get into your low bit rates, like 32 or 64, or even lower than that, lower than 32, they're having to do a lot more masking. They're having to do a lot more guesswork. And that's the reason that, for example, the highs are very swishy. Because another thing that they do in these codecs is they add noise, good old white noise, to help hide some of the artifacts. The codecs are getting better all the time, but still, I would be very reluctant about trying to put any audio on air that's less than 128 kilobits. And the more, the better. And you're going to have problems with that because everybody wants to compress, because that lowers their drive space, that lowers their bandwidth when they're shooting it over the internet. Everybody wants to compress the daylights out of it, and they're going, well, this sounds good to me. Well, you obviously have peanut butter in your ears. It does not sound good. And as you probably know, each time you encode audio, more of it gets damaged. We're talking about a lossy codec like MP3. So you take that MP3 that's only 64 kilobits, it doesn't sound too bad. Listen to it on your HD stream. It's going to be almost unintelligible. Or something that we do, if we have a catastrophe and one of our STLs just goes completely out, we will pick up a multicast off of one of our FM stations and use that as an STL. But at the receiving end where I'm using that HD signal, multicast, I have to turn off the HD. Otherwise, people with an HD receiver, it will trigger on and it's unintelligible. Sounds like the world's cheapest fuzz box. It's horrible. And if you don't believe that, you can do it by take an MP3, play it, and record it as a pure uncompressed wave, then compress it again as an MP3, play it back as an uncompressed wave. Do this through several generations, and it won't take you very long to get to where you can't even understand what's being said or what's being sung. All right. Now, we want judicious use of loudness. We do not want to be loud just for the sake of loudness. This is the Beatles song, Something. There's something in the way she moves me. You remember the song? From different eras. And you can see that the record companies have discovered processing. Unfortunately, they want to squeeze and smash it as badly as any top 40 radio station. And so you can see, and by the way, this is an old image. There's no telling what it looks like now, although maybe I can find one that'll give you an idea. Incidentally, I remember Frank Fody, it was either Frank Fody or Jeff Keith at Wheatstone told me that they actually have had, anyway, some years ago, recording studios were calling them up going, look, can we get an Omnia or can we get a Vorsys, or they'd call Optimod? Can we get an Optimod? But we don't need the FM stereo generator stuff. We don't need any of that. All we want is the multiband compressor. And there's the result. Here's one. Let's see if that GIF works. Yep. This is ZZ Top's Sharp Dressed Man. I realize the print's kind of little. Let me give you the dates. There's 1983. That's the original. The year 2000, you can see they're starting to smash it. Look at 2008. Look at that. That's one of the reasons why the better processors, and unfortunately they do cost more, better processors know how to relax when they see something like this, because they're thinking, okay, the dynamic range has already been pretty badly limited, so I'm not going to do a lot with that. And basically, I'm just going to make sure it doesn't overmodulate. Now for overmodulation, speaking of which, hopefully none of you guys have ever had a manager or a program director come to you and say, look, I believe WXYZ is overmodulating. We're going to have to overmodulate to compensate. Understand what decibels are. The original was actually the bell, 10 dBs. That's 10 decibels. The original bell basically represented 2-to-1 ratio in loudness. I mean, that was Bell Labs. Now, admittedly, it's for speech, but that's still a pretty good idea. In other words, to modulate 140%, you're only going up by 3 decibels, which is not that noticeable. A little bit, not much. You'd have to go to 200% to get a really noticeable increase in loudness. And you can prove this to management with a very simple test. Let me find my Zoom screen here. There they are, meeting controls. Let's go back to get rid of screen share. Somebody tell me how I go back to me. I've already forgotten.
You're looking to stop screen sharing? Shove the mouse up to the top of the screen. You'll probably get your green bar.
Yeah, I got the green bar. I don't. Oh, pause sharing. Stop share. Got it. Look at me. I'm an engineer. Do not try this at home. All right.
We are trained professionals.
Dangerously trained. Here's one I want you to try. I don't need to show you fancy or ugly pictures for this, but here's one I want you to try. Take the... somebody pointed out, Anthony pointed out that high frequency makes those codecs go nuts. That's absolutely true. I agree about the noise too. Unfortunately, there's not much we can do about that, except make sure our stuff doesn't have noise. I want you to take some audio, preferably some speech. Go into a control room, production room, go into a room with some good speakers where you can meter the monitor level. I want you to set the audio to where it's averaging, right around 0 dB, right around 100%. Tell them to close their eyes or turn around and lower the sound until they say, okay, and they'll tell you when they think it's half as loud. Don't be surprised if the meter is now reading 10 dB less. They will not want to believe it. That's something you have to show them because people just do not want to believe it. Another trick about modulation, as I said, is modulation density. There have been times I have set up transmitters and we use very dense modulation. I mean, with a Vorsys or with a good Omnia, you can get some very dense modulation. And I'll be, just tinkering, setting up a new transmitter or something. And I'll think, well, that sounds pretty good. Okay. And then I happen to look over at the modulation monitor. I'm only modulating about 80 or 85%. Again, you're only talking about a change of a few dB, and you really are not going to notice it that much. Here's one other test you can try. Write this one down. You can already know about the 10 dB. Here's another good one. Take your audio, very compressed, and also some audio that is not strongly compressed. But to be fair, it is dense. It is peak limited. And I want you to take that extremely dense audio and turn it down and ask them when they hear a difference. Compare. You will find out that you doing 100% modulation with audio that isn't dense is actually not going to be as loud to the listener as when you're doing 85 or 90% with very dense modulation. And these, again, are things, think up your own examples. These are things that you can show people because they're not going to want to believe it. Like if you say 10 dB is twice as loud or twice as, or, half as loud, they're not going to believe you. You have to show them. Try it with white noise. Try it with voice. But you show them that, it will open their eyes. All right, let's go back to share screen because I'm having a ball with this. All right, there you go. I'm just curious. Yeah, 80% is only minus 2 dB. 1 dB is considered the minimum that somebody with excellent hearing can possibly detect. 3 dB is the threshold that most people will detect. They'll begin to say, okay, there's a little difference. 6 dB is a noticeable difference. 10 dB is half as loud. Again, try it out. Don't take my word for it. Now let's see what we have next. Here we go. Oh, that's a video, which I wasn't able to play. We're not going to try that. But I'll show you. Okay. Why won't he go nowhere? Go away. Move. No, not that way. Let's go this way. Oh, that's the last image. That's why. All right, now we have some audios. Let me play that. Aha. That's in case somebody wanted to see some of our processes in progress. I'm downloading a VNC program. All right, let's see. You need to go away. Let's open our files. Go to our USB drive. Here's an interesting one. I hope you can hear this. It's not guaranteed, but I hope you can. This is 1 kilohertz with 1.1 kilohertz. That's what this video image showed you. Yeah, and it's not going to play, is it? Well, why don't you double click it, idiot? But what you'll hear, can you hear that? That's the 1K. Now it's adding 1.1. By the time you lower the level of 1.1 by just 20 dBs, it disappears. It's still there, but you can't hear it.
I think you've got to set your computer to accept, for Zoom to accept computer audio.
Let's try that. Share sound. There we go.
There we go.
All right, let's restart it. Now there's 1 kilohertz. Add 1.1. Now it's only 20 dBs down, but it's disappeared. Listen real closely. You might still hear it in there. Let's see what else we got here. Oh, yeah. I couldn't find a picture of the old DAP. That broke my heart because he basically created multi-band processing. Let's see. I've got this in the way. I am missing some images. I should not be missing them. It's very distressing. All right, let's try this. Okay, documents. My picture.
Just remember, while you're going through your pictures, we can see it all.
Yeah, there's nothing illegal or ugly on here, promise. Well, we can always look at the manual for an XL60 or the NX or not.
So, Tom was wondering if there's a preferred audio processing setup between audio bandwidth and peak modulation for best listening quality for AM ground wave versus AM skywave.
No. Skywave is going to sound different simply because, let me end sharing. Skywave is going to sound different simply because it's going over long distance and has a chance. It has a chance to pick up a lot more noise and distortion. When I talk about reducing bandwidth, and I'm going to show this to you, we'll set up some processes. In fact, I want you guys, whenever we get near the end, to tell me what you're using for processing, because then that'll give me an even better idea of what we can look at. But I've already said, try to cut your base a little bit. Cut your base. And possibly roll off the highs a little bit. And there's a trick there that we use called the 500,000 rule. You may see it online as anywhere from 400,000 to 1 million. But basically what it means is base limit times the high limit should roughly come out to about 500,000. Which, if you take that seriously, the 15 kilohertz top end limit on FM, that means your base, you really don't want much below 60 or 70 hertz. And yeah, we do 50 to 15,000. Like I said, it's not a hard and fast rule. But processing, audio bandwidth, and peak modulation, AM, you can improve your loudness just a little bit with doing 125% positive. I know I said that doesn't amount to much as far as decibels, but that does help. Best listening quality for AM ground wave versus AM skywave. I don't think there's going to be that much difference to the receiver. I mean, I'll take opinions on that. Any of you guys, old timers, been dealing with AM since Moby Dick was a minnow? You got any opinions? I don't think there's going to be any difference. I wouldn't want to, obviously we want to be good neighbors at night. We don't broadcast anything over 5 kilohertz because we don't want to jump on another channel. But, cross over into someone else's territory. But, and at 5,000, we limit the base to about 90 or 100 hertz, and it sounds okay.
We've had, Stephen, this is Tom King, just for a moment. We have a lot of discussion with international broadcasters that are broadcasting, long ranges with high power, medium wave. And there seems to be a lot of disparity between the thoughts as to how to achieve, particularly at the skywave, nighttime skywave. If you're trying to extend coverage, into the fringes of your pattern, what is the best way to achieve that? And some people are thinking, narrower bandwidth and higher peak modulation it yields better results, and others, the reverse of that. So I was just curious from your standpoint and Crawford's standpoint, what you found to be the best best situation for each of those. And I appreciate that. Thank you.
Yeah, well, and I appreciated you, Tom. Good to talk to you. I assume this is the Tom King whom Chris and I know.
Yes, it's Tom King, Kintronic Labs. Yes.
Hello, Tom. If you ever need anything done for an AM, from fresh dirt to a tower, call this guy. All right, Tom. To be honest with you, we really don't do much different. We like I said, now we do limit our bandwidth to 5 kilohertz. We still do. I think we're still doing 125% on positive. And like I said, I do cut the base at around 90 hertz, 80 hertz, 90 hertz. And but then I do pretty much the same thing during the day.
So what is the audio bandwidth you're running?
Right now, we're running about 90 to 5,000, which I'm not happy with, but then most car receivers now are so bad that I am only wasting modulation energy by trying to push it out to 10 kilohertz. I'd love to. But also because we're running HD, we want to make darn sure that we don't put any kind of spurious products up into the HD subcarriers, which theoretically we shouldn't.
So you're running HD AM as and an analog, analog and digital signal on the AM at the same time.
Yes. Yeah, we're doing the hybrid mode. We have, you have a carrier above and a carrier below. in the adjacent channel, which makes everybody very happy. So who's this having technical difficulties? That's funny.
Oh, that's Anthony, our gentleman telling us about codecs and noise. He's a very smart guy.
Well, he needs to quit having technical difficulties because he's probably smarter than me. Not that that's hard to do.
I think he's just adjusting his green screen.
There you go. Yeah, I was thinking about a green screen myself, but then gave up. All right, let's go back to speaker view. Sometimes speaker view drives me crazy because every time somebody goes, all of a sudden their picture pops up for a second. This is the noise of a host versus a phone caller. The noise shape is very detectable.
If you're looking for us to see this, you need to share screen.
Oh, I'm sorry. I'm reading the chats. That was from Anthony. I'm sorry. He was. How do you process phone calls? The answer to that is the best you can. Especially with everyone wanting to call in on a cell phone now, and so many of those are very low bit rate codecs. I'm on Verizon here in Alabama, and they boast about their HD audio. To me, it sounds like pure trash because the high end really is nothing but noise, psychoacoustics, and fakery. It drives me insane. You put that on air, once again, going out over your HD. From what I understand, the smart guys at Omnia and Vorsys and Optima and all the other good people, they're working on ways to reduce the grain and grittiness before it gets out over the air. And I'm anxious. I know Omnia has what they call their declipper, smart declipper, which helps a lot. And if I'm not mistaken, I remember we're not using that Vorsys right now, but if I remember, they have a undistorter or a declip or something like that. That helps a lot. But basically, somebody calls up on a phone and it's like an 8 kilobit signal. It's hard to make that sound good, and it's going to be very difficult to get it to sound good on an HD stream.
But does my audio work? Did I get audio back?
Yes, you did.
Oh man, audio sucks.
Hello, Anthony.
Thank you for job security. And so my question was more about like shaping noise from caller to caller. So the example that I brought up or sent in the link in the chat was more about like how do you make like a conversation cohesive between like caller to caller and guests? So like somewhere right now I hear your furnace whistling, for example. Like I hear, right? You hear that little beating that happens in the background, and then you mix my noise in with other noises. Like I don't know if anybody else has been listening for this stuff, but at the CBC we get a lot of callers, a lot of people. They talk about the noise between guests, and they hear people turning their mics on and off and on and off and on and off. And the link that I showed was the difference of the noise between a caller coming in and the person in the studio. And that used to be like perfectly tolerable, but the callers are actually coming in quieter than some of the studio stuff. So there's a need almost for noise matching. So I was just curious to see if you had a take on that, or if anybody else is having that same kind of weirdness.
We, as a general rule, if somebody calls us up with a really weak or bad sounding call, we won't put it on air. Or we'll hurry them off air. We'll say, look, your phone's messing up. We can't talk right now. I mean, like I said, all you can do with putting phone conversations on air is the best you can do. And you also, that's another one you're going to have trouble convincing management and programming of, is that cell calls drop. They'll be fine 1 minute and then horrible the next. I mean, it's just something you have to deal with. And let me tell you this: I've listened to nationwide top tier talk shows, and they have the same problems. And what they'll do is what we have to do. We'll just say, "I'm sorry, your phone's breaking up. We can't put you on there."
Yeah, well, sometimes
sounds bad.
Editorially, sometimes you don't have that option or luxury. So, like our prime minister has a terrible press feed, and you take it or leave it, right? Like,
that's
leave
when
it.
You can try a little EQ on either bass or treble. Either way, try a little EQ to get rid of some of the gunk, and then just put it on with a disclaimer and say, that's what we'd have to do. We'll just say, look, I apologize for the quality of the audio. I apologize. That's all you can do. The best you can do. If you're asking, is there a magic technological fix? Not that I'm aware of. And if anyone out there
series of them,
I want to hear it.
Okay, I could speak to 6 or 7.
What do you mean?
So we do cedar noise reduction, noise matching, so dynamic learning of noise shaping and noise shaping patterns.
Yeah, now we tried that. How do you when you do that? How do you like taking live calls on the fly? That's right. Not so easy.
Well, but what is a live call? But right now, I could put you to air. Right, and this is a Zoom. I could get your Zoom. I could get Charlie Donor. I bet you his audio is really good today.
No, the way we do it, the only thing we put on is like if Granny calls because she wants to sell a chicken. Remember, this is Alabama. Or we're doing a talk show, and the governor has announced that he's going to kill anyone with a last name that starts with the letter P. What is your opinion? And that's when, everybody comes out of the woodwork. That's what we do. Now, as far as like long form,
just any form, like right now we're in the world of podcasting and noise, right now your room sounds really good. I would say, probably the best advice I could give to anyone making a call or anybody who's phoning in is what you got to do is you got to stay in one place. This is the rule. This is what I say is you stay in one place. You try to make it as quiet as possible with like a go in a closet and stay in one place and talk to me. Right. So that's number 2. That's the best advice I could possibly give.
That's good.
And don't concentrate on what your face looks like. Right. So if you're just giving a radio interview, if you talk closer, and you get closer in, that's what it. 3, avoid Bluetooth. Bluetooth is shit. Sorry. Who else is here? I apologize. Language. Bluetooth is terrible. You're wired. No engineer will be above wire. We're a lot of FM and transmitter people here. So, avoid any transmitter. That'll help. That avoids noise. So anyway, that's the 4 that I usually give out. So that'll increase quality of calls.
Yeah. But I said, what we'll do here, maybe you don't have this luxury. We can just tell people if it's too bad, we just say we're not going to put it on air. And maybe you don't have that luxury. And maybe you need to take up a collection and buy some higher bandwidth and a better telephone for your prime minister.
Yeah, well, that's smarter than
Just kidding.
Battery powered press boxes, so nobody gets COVID while they plug in.
I know. Let's not go there. At least your prime ministers and governors and other speakers up there don't sound like Meemaw. Our governor here in Alabama, bless her heart, she sounds like a female version of Foghorn Leghorn. And she's just sweeter than candy. Love the old woman, but try putting her on there and people going, how do you process that? You don't. There's no, you try to run it through noise reduction, everything would disappear. You'd have silence. So sometimes you have to do the best you can do. But now, incidentally, all right, what is this? Brad Butterworth has set a chat out using separate means outside of POTS to capture audio. I agree with that. I mean, obviously, it's GIGO, garbage in, garbage out. You want the best possible audio you can get, which is why I made my comment about low bit rate codecs. You know, you got these advertising agencies that will send you a buy for a million spots at $100 each, but it is so terrible. You know, well, no, with that kind of money, you're going to put it on there. For that kind of money, you'll mic a lawnmower. I mean, for that kind of money, you'll air anything. But yeah, it's a problem. I'll show you something if I can get this to come up on the screen sharing, because this may be part of what Anthony was alluding to, even though this wasn't really what he was exactly talking about. All right, let me close this. Everybody's got their favorite digital audio workstation. Is that sharing? Can you see it?
Yes, we can.
Good. And this, even though this is not Pro Tools, it's not the most expensive one on earth, this is where you could possibly be a hero to your folks by showing them some of the plugins. However, I have a very powerful caveat on that in just a minute. Go away with empty project. Thank you.
A problem is they're addictive. And they cost small fortunes to maintain.
Well, I'll go ahead and be talking just so we won't have dead air, if you follow me. But one thing you need to do, no, there's no instruments. So, well, I can't show it to you. May their faces ignite. Hope they burst into flame. Let me pull up a project that exists. But, edit. Wave editing. What you can do, here's some of our effects. Restoration, you've got a declipper, remove DC offset. They also have a very good noise filter. And of course, I can't find it now. I don't normally edit on this machine because I despise the touchpad. The caveat, what I was going to warn you about, is you don't want to use, okay, how do I bring that back up? Hello? Ah, there we go. Can I have a full screen now? I've got a tiny little itty bitty box. There we go. Okay. I'm just an engineer. Don't try this at home. You're going to be disappointed if you go play with some of the plugins on digital audio workstations. Now, like I was just saying, the noise reduction, noise elimination stuff that's built into that Magic Samplitude is very good. And from what I understand, there are some even better ones that are, just for noise reduction, cost several $100, but I mean, they're just amazing what they can do. They also have, things like compressors, limiters, all other kinds of dynamic range controllers. These range from absolutely horrible to barely acceptable, and none of them are going to be suitable for use on air. Your STL's down, a car ran into the tower and crushed the little dish. You're heartbroken, but just to get the station back on, you run a laptop out to the transmitter site and you pull up a program like what I just showed you, and you try to use their built-in compression or limiting to keep from overmodulating. It won't work because the people who design these things don't think like we do. We think in terms of, if I continuously go past 100%, I could be fined. or if we overmodulate, whatever the service you're in, it has different limits. Some of them do. But they don't look at it that way. Another one, I'll go ahead and tell you, this is the truth. I was going to make up some audio to show you what ducking, even though a lot of you, I'm sure, have heard it. Ducking is whenever you have a normal audio playing. And the best example, especially on one of those old RCA or stay level limiters, was the guy talking into a microphone and he thumps that stand. And that deep bass boom just crushes the audio for several seconds. He's like, we're glad everyone, boom. And you go, can be here today. That's called ducking. Sometimes you do it on purpose. You have ducking, then you have pumping. We had one program that we aired. This was a religious program when I first started in radio. Somebody had re-recorded that intro. Must have been a half dozen times, and each time it ran through an Automax. So by the time I got to it and was airing it, it would be, you have been listening to preacher so-and-so. You can write him at, and I'm sitting there. I look at the modulation meter, and of course, it's not even moving. All right, there he is.
Have you ever heard of there's a plugin that I used actually quite a bit. It's called Broadcast. It operates almost like a mini Omnia 3.
Now that might work. I'm sorry, when I say all plugins, I know there are some that actually work, and they're intended to control peaks and not just average levels. But no, I've never tried that one. I have tried Optimod has a PC-based processor that's very good. And I think you can plug it into your workstation. That's very good. We've used that.
Yeah, this one's actually a VST plugin, and it's free. And it actually has AGC, limiter, pre-gain, everything. It has a bunch of adjustments on it. It's actually impressive for a free plugin. And I've actually had the situation where you were just talking about where, we lost our studios and I was on a laptop at the transmitter site, and I actually fed our audio through a VST host running through that plugin, the broadcast plugin, to keep us on the air. And all I had to do was tell the exciters, I turned on the limiter inside the exciter to not go over 100%. But other than that, it actually didn't do too bad.
No, I believe that. But I guess when I say...
Sorry, I ran into that problem with the limit, and that's why I had to turn on the exciter's limiter.
Anybody ever had an old Gates MW or Harris MW1 with that wonderful modulation enhancer? It basically was a set of back-to-back transistors. If I remember correctly, I think it was a PNP and a NPN, to clip different peaks. And that's all it did. It was just a hard brick wall clipper, and it sounded like dookie. But there were some people who used them. They would drive that transmitter hard, extremely happy with, and I'm going, you do know that sounds terrible. Hush. We're making money. Okay, whatever. I'm glad for you. There we go. All right, I lost my chat screen for a minute. All right, where are we at? It's almost noon. Let's, you guys, either by chat or by voice, tell me. I have always believed in hands-on. We're going to do the next ones at the studios, my studios, and I'm going to pull out the processors or either show you actually what we're doing. And I've got to figure out a way to let you hear it, which I know how to do that. It's just I didn't have that stuff here at my house. Hey, I'll be using a USB mixer. Anthony, USB mixer. What do you think of that?
I'm using Bluetooth headphones. Sounds not bad. I can go on air. I could go on air. They wouldn't reject me. I think, but the thing is, I'm in a shut off kind of room with cloth around me, and that's a huge deal.
Actually, there's, you were CBC Radio Canada. Good for you. Give me some ideas of what you want to talk about, because believe me, today was just to get to know each other.
Oh, I really like this format. There's nothing more than engineers arguing, and about points and stuff. Like engineers are arguing with an engineer is like wrestling with a pig in mud. After a couple hours, you realize the pig likes it.
Right. And you're not accomplishing anything except getting muddy yourself.
No. Well, but I really like the topic of listening and noise and stuff, and the closer broadcast. There's a power. I'm looking at the chat list, and there's like colleagues here that are just amazing here. It's so good to see everyone. There's a combined knowledge of 200 million linear hours happening simultaneously with the people in the room here. So it's pretty cool to have that kind of conversation. But for us, it's a lot of talk radio, right? It's a lot of callers. It's a lot of Zoom calls. It's a lot of filtering that stuff and making it cohesive, coherent through automation, not through people. So having some kind of systemization to use those plugins, like you say, all these plugins. But how do we use them in real time to accomplish the things that we need to do?
I got you. Let me look into that. That's and look, I learn as much from doing these as you guys could ever learn from me. I learned things just preparing today. It's fun. But I'm going to look into that. How do we improve? I'm just saying Zoom audio, but I know what you're talking about. It's basically, I'm going to say low bit rate. What else? Anybody else?
There's some. Oh, I have many things that I would love to learn about. OSC, so Open Sound Control. So this is a new control protocol. So there's a thing for Zoom called Zoom OSC. And what it allows you to do is remotely tweak the parameters through an API of Zoom calls. So you can actually use OSC, Open Sound Control Protocol, to control such things like the tally box around me. You can shut it off, turn it on. You can mute some. So you can do all of those things for call-in shows using things like Zoom OSC. That kind of stuff, I'd love to learn more about.
Now, see, I just learned something. I know how to use Zoom just enough to be dangerous. I'm not really an expert on it. I never even heard of that. I made a note of that. Thank you.
I'll put a link in the chat.
What kind of processors are you guys using right now? I wonder if I should. Let me see. Well, they won't switch screen. Why won't it switch screen? This thing hates me. We've still got Anthony up. Hi, Anthony.
You need to go to the upper right corner and click on view, and then you can get multiple people, Stephen.
Yeah, that's what I've done. And it's like,
we got a few people in with the chat that are rhyming off. Looks like Omnia is the winning one at the moment.
Hard to beat an Omnia. I've never seen a 7. We have some older 5s and 6s. We have a couple of 9s. We have some 11s. Omnia 3 FM. That was an amazing little processor. I love that thing. Symmetrics for mics, right? We've done that. We are currently using, at our studios, we're using the WheatNet, the Blade 3s that have the built-in Vorsys mic processors. You have to be careful setting them up. Hey, we'll discuss that too. Who is TC? Anthony, you said TC.
It means take care.
Oh, take care.
Take care. Okay. No, it doesn't.
I thought it was a TC processor. I ain't never heard of that. But it's good.
TC is a Danish company. I believe they're Danish.
I know.
They were just
I need more coffee.
Acquired.
It looks like we got a lot on you. Anybody using Optimods?
Yes.
Okay.
I used to have the Vorsys 2000. I like that box. Well, it's really old now.
Yeah, well, still got a couple of the old HTPs, which is one of the first ones they ever made, and they still work. We had them on our streams for a while. I like to freak people out. When we put in the Omnia 11 on WDJC, we took that Vorsys Air Aura 3. I mean, it's not the 1, it's the 3, and put it on a stream. Just so people would come in and go, "You're using a $16,000 processor on a web stream." It's because we care about quality. No, it's because I had an extra. And
actually, I'm using that broadcast. You know that broadcast plugin? I've actually used that on all our streams for all our stations.
We do. All right, we do that. We're using plugins for that, for streaming. Now we are, but back in the old days, I just whatever. I had an old Omnia 3 left over, threw that in. Whatever I had laying around. Yeah, which is how I learned the trick. I'm sorry. Go ahead.
Sorry, yeah, we use what's called the Rocket Broadcast Encoder, and it allows you to throw a VST plugin into it. So I put the broadcast plugin into it, and like I said, it operates a lot like a little Omnia 3 FM turbo, and it does a pretty darn good job for what we need to do.
Listen, I don't know how many of you guys do any programming or hang around on the geek sites, but I'll let you on. I'm not taking anything away from Frank Fody or Jeff Keith over at Wheatstone, and actually Steve Dove. If I'm right about this, Steve Dove is the one who does most of their codec or does most of their programming, not codec. But guys, there's a lot of public domain open source stuff now that I honestly believe some people are taking it and sticking in boxes and saying, "Look at our brand new processor. It's amazing. It will raise the dead, make coffee, and it's only $1,500." And that's what you're going to be seeing more and more in the future. These DSP routines. I am a programmer, and I got to tell you the truth. When I look at some of these the code for some of these DSP routines, my hair catches on fire and my eyeballs cave in. That stuff is just amazing what it can do.
Yeah, it's because it's built for DSP chips, not for humans.
Oh yeah, I know.
You can't possibly take it all in.
Hey, if I wanted to, I could. Because I'm an old timer, and you need to get off my lawn, whippersnapper. All right, is there anything else, Harry? Anything else, or do we need to let you say goodbye, or can we all sing Kumbaya?
It's not a scout meeting. But we're probably all former scouts anyway. Well, thank you, everyone, for coming. Thank you, Stephen. It's been a great hour. 2 weeks today, which is, I think, March the 8th. We'll all be back.
And look for goodies.
Yeah.
We're going to have goodies for that one.
So thank you all. We'll... what's Mike talking? Volt processor. I saw the 11, and I was thinking it was 11 volts. He was trying to send voltage measurements as opposed to, I guess, the Omni 11 and then the volt.
Frank Fody's a genius. I'm just telling you, he's a genius. Steve Dove is too. I mean, they're just geniuses.
Steve is amazing. Yes, Steve wrote some fantastic papers on mixing consoles. He wrote like a amazing 6-chapter, like how a mixing console works from the ground up. It's an amazing read. Like it's published in many books, and like it's one of the best reads I've.
Well, he cut his teeth. He cut his teeth traveling with AC/DC. And
you can tell by the beard.
He's something else. He's a super nice dude, super guy. All right, well then I am going to sign off. Good gentlemen, everyone have an absolutely beautiful day.
Thank you, Stephen. We'll see you in a couple of weeks. Take care.
You got it, my friend.
Stay away from the icy roads.
You in Alabama?
Stephen.
Yeah, absolutely.
All right. Thank you.
Thanks
very
everyone
much
for
again.
coming. Hope to see you again in 2 weeks. Same time.
Wicked. Cheers. Good to see you all.
Good to see you, Anthony.